So to do some brief introductions, we're going to discuss a little bit how Taranis AI works. I think that we've had conversations in the past and put out some things that we've talked about, just general AI conversation. But we have really unique technology here at Taranis. And so I'm joined today by one of the guys that helped create it all. And so why don't we do some introductions here for the group that's watching today.
Okay. So my name is Gershom Kutliroff. I'm the CTO of Taranis. I've been working in the field of AI since my graduate work, which is about 25 years. At first, it was really around computer vision, being able to understand what's in images and video in a way similar to what humans are able to understand. And of course, in the last 10 or 12 years, the field has kind of exploded and it's moved into other areas as well, most notably what's called Gen AI.
And so we have a couple different versions of AI that we utilize here at Taranis, and we'll talk about a few of those. I think the important one is what is leaf level AI? So that AI that we use that determines tagging, what is that, and is it unique to Taranis?
Okay. So leaf level AI is what used to be called computer vision. It's about being able to understand the content of imagery. And in our case, it's the images that we capture from the drones that we fly over the growers' fields. We fly those drones and look for signs of disease and different weed species, insects and insect damage, and of course also count the plants for our stand count insight. And the underlying idea behind really all of AI, at least all the techniques that are used in AI, is that it turns out to be much more effective to gather a lot of data that kind of represents the problem or the problem that you're trying to solve. So in our case, it's lots and lots of data of growers, fields, and plants at different stages and in different environments. And then just throw that into an algorithm which massages that data. You tell the algorithm what you're looking for, so what are the correct answers, and the algorithm figures out the best way to find those answers, to correctly assess, to match the ground truth with the data that you've given it to train on. So that's been a very powerful idea because it's turned out to be a lot more effective than doing it by hand, and people sort of looking at the image and trying to figure out, how do I recognize what's in this image and how does human visual system work? It's much more effective to just throw it into one of these machine learning algorithms, a huge amount of data, and let the algorithm figure out what the best way is to recognize what you're looking for in the imagery. So because of that, what really determines the quality of your solution more than anything else is the amount of data that you have and the quality of the data that you have, because that's how the algorithm is learning to find what it's looking for. And that's really something that differentiates Taranis in the marketplace, because we've been doing this for almost 10 years. We have hundreds of millions of images that have been very, very carefully tagged for exactly what we're looking for. Most of them were captured with the drone equipment that we're using today. So that really is unique. Nobody has that kind of a rich data set of imagery like Taranis has, which is why our AI models are really excellent at working on this imagery to identify what we're looking for.
And I'm looking forward to talking more about how it works, right? And one thing that I feel like a lot of our growers and partners ask is, well, how sure are you that what it is actually tagging is correct? And so maybe tell us about the threshold of acceptance and our sensitivity to determining what is a corn plant, what is a weed, what is a certain disease, things like that. Just high level. Is it 100% accurate?
Yeah, I think it's not 100% accurate. I think that the best way to understand the best analogy for how these models are working is to think about what it would take to get a person to be very good at identifying all of these things. And naturally, what you would do if you wanted to be highly trained at identifying all of these different phenomena in the field is you'd go out to the field and somebody would show you a plant and say, this is this type of disease and that's this type of weed. And as you see more examples and you see examples of those phenomenon in different environments, maybe with different hybrids, different varieties on different plants and on different soil, you get better and better at identifying those phenomena because you've seen more. So that's how you learn. That's how you kind of train yourself to be really good at anything, but agronomy in particular. And so the model is doing the same thing. So when we're um, when we're training the model with all of this data, the model's getting better and better at seeing the phenomena that we're looking for, detecting the phenomena that we're looking for in all of these different environments, on all of these different fields, in different regions, with different environmental conditions. So based on simply the amount of data that we currently have that we've trained these models on, that's likely much more than any human's going to be able to go through and be able to learn how to identify all these different phenomena in all these different environments. So I would imagine that the model does a really good job relative to, let's say, what a human expert could do. I would also add that a lot of times this kind of work can get rather tedious, walking through the field and just looking at these plants. And the human visual system has evolved to really be able to notice things that are important for humans to know. And it's not great at staying focused when you're walking through a cornfield and looking at different plants for hours on end. But the AI models have no problem with that. They have not evolved in the same way that human visual system has evolved. So they're going to notice every phenomenon on every image that people might otherwise miss. So the model is able to do a really good job in this area that people maybe aren't too excited to do it, and they're not really that good at doing it. And then if you use the results of these models, so then you can go ahead and do what people are good at, which is figure out what to do given the data that the model has delivered to you.
That's really important. I think there's a couple of different analogies that some of our folks have used. One of them is I really like one of our sales rep, Tim Pearson. He uses this all the time. He says, AI didn't oversleep. It didn't wake up with a stack of papers on its desk that it's got to sift through before it goes out and looks at a field. It didn't stay up and party too late last night and doesn't really feel like walking fields. It has a job, and that's what it is there to do and serve. So one thing, as we dive deeper and maybe into some basic understanding on how our AI algorithms determine what a specific insight is, I think one analogy that I've heard us use is, you have two Coke cans next to each other. One of them is a regular Coke. One of them could be a Coke Zero. There are differences in those two cans, and so as we kind of work through a list of, let's just call them check boxes of, is it the shape of a can? Is it red or black? Is it have scriptive letters? All these things, and then ultimately it gets to a point of confidence to be able to say this is a Coke Zero can, this is a regular Coke can. Maybe describe some of that and how, if we're looking, for example, at a disease like tar spot. Tar spot, symptomatically is showing black speckles on the leaf of a corn plant. And so maybe walk us through that process of how it determines and actually says yes or no, this is the level of confidence that we have in making this decision.
Yeah. So actually, it's interesting. I like your analogy about the Coke and Coke Zero cans. And when I started in this field, that was really how we worked. So we would try to identify, what are the features? Those are called features that differentiate one object from the other. And one feature might be that the color, there's different colors on the can. Another feature might be that the words say different things. Another feature might be that one of the cans is a different size. And so you'd want to detect all those features, and you'd kind of put them together, and then you'd logically decide that this must be a Coke can or a Diet Coke. And then when the world of machine learning really exploded, and you have now these techniques that are based on machine learning, so you don't do that kind of choose the feature and decide when it's applicable, when it's not applicable. Instead, you just gather lots and lots of images of Coke cans and Coke Zero cans, and you throw them into the algorithm, and the algorithm says, and you tell the algorithm which is Coke and which is Coke Zero. And the algorithm decides what are the best features, like all of those defining characteristics, in which to identify those to differentiate between those different objects. That turns out to be a really sort of the key, very powerful technique in order to train these AI models to be very accurate at differentiating between different objects. So if you take the example of tar spot, it's not any different. Rather than trying to, think about if you had to describe in words all of the different ways in which you would want to identify tar spot. Look for little black dots, but black dots in a particular shape because you don't want them to be, insect droppings, or you don't want them to be, drops of moisture that can sometimes look black on the images. So think about the challenge of, writing up a description of what you'd want to identify in those images, and that's going to be very tedious and probably not so effective. Alternatively, think about, okay, I'm just going to show you these two images, and you can see clearly this is tar spot and this is not tar spot. So that's what you're doing for these machine learning algorithms. You're showing them the images, and you're saying, look, you figure out what the best way to understand what I'm telling you is in this image, the best way to describe it. I can't describe it to you in words, and I'm going to give you millions of these images, and make sure that you're correct on all the ones that I tell you are tar spot, and that all the ones that I tell you are not tar spot, you identify them as not tar spot. I don't know what all of these little differentiating features that you're going to use within the image to differentiate between them, but as long as you get those answers, as long as you correctly identify what's tar spot and what's not tar spot, I don't really care. That's going to be the best way for me to be able to get the results that I'm looking for. Is that
Yeah, and that's across all our insights. Tar spot's a good example because I felt like that example is one that is really important for making decisions on fungicide and timing of application and things like that. So okay, so now that we kind of understand a little bit more how our leaf level AI works, one thing I want our partners to start thinking about how to utilize Ag Assistant. The importance of this tool is really to create a quick summary on what happened during a specific flight and what decisions could be made because of that. So, how should our partners think about using recommendations in season based on Ag Assistant? Maybe talk a little bit how Ag Assistant was created.
Sure. Well, I want to go back to something that we spoke about earlier, which is that it's kind of a tedious and not very enjoyable process for people to walk these cornfields and identify all these phenomena by themselves. So the idea really of Taranis was, okay, let's do all of that tedious work automatically, and let's just give our customers the results so that they can know that we found something that's likely tar spot, or we found this type of weed in the field, and then you should decide what to do about it, because that's what humans are better at. And so Ag Assistant is really the same concept, which is after we got really good at running all these AI models and identifying all these different phenomena in the fields, we started creating a lot of data. So there's a lot of the outputs of what's in your field. It's in this part of the field, and we found it in this mission, but not in the next mission, or We also have historical data, maybe on the field. We also found these types of weeds in the same area in the field. And likely a good agronomist who's looking at these insights in order to understand what to do about them and what recommendation to give the grower is also going to pull in other information, like he knows what the weather has been. Maybe he sees some nutrient deficiencies and he knows that he put on fertilizer, but there also hasn't been any rain in the last 6 weeks. So there hasn't been uptake of that nutrient from the soil. And so he's bringing in all of this additional information in order to help him understand what's really happening in the field based on what he's seeing, to give a recommendation to the grower that's best going to service his customer. And so as we started generating more and more data and started to understand that really there's all of this additional data that you'd really want to pull in to give a good assessment of what's happening in the field. And we realized that we're revisiting the same problem of, we're creating a lot of work for an agronomist who's trying to do his job well, and we can really help him out a lot here because we can actually go up another level. And instead of just giving him the results of our insight and leaving it to him to do all of this additional work, we can actually do a lot of that work for him and present him with something which gives him a much better idea of what's really happening in the field. So, maybe it's not enough to say your stand count was 92% of your target population looks good. Maybe we also see that the coefficient of variation seems high. So there was some issue there around planting, which you should be aware of, because even though your stand count's at 92%, you may not get the yield that you would otherwise expect to get if you have for 92% of the target population. So there's all this additional information that we can provide, which lets him give a much more targeted, relevant, and useful recommendation to the grower about what's really happening in the field. So I would say, in spirit, it's what we've always been doing at Taranis, which is to do all of this sort of tedious, time-consuming, not so exciting work to be able to give the agronomists and the growers, by extension, the growers, a good sense of what's happening in their field. It's just that Ag Assistant, by using these Gen AI techniques, lets us move that up a level and also synthesize all of this additional information about coming from other sources to really give him a much more comprehensive understanding of what's happening in the field.
That's great. Well, I think that's all the time we've got. Thank you, Gershom, for your experience, and really kind of to wrap things up. I think all of our growers, our partners, can understand that now you can trust the insights and pair them with your agronomic knowledge, because that's the most powerful tool that they have, and then being able to utilize the information and the data that we are in turn, arming them with, they can make better decisions and help their growers become more profitable, and in the long run, help them save a lot of time and a lot of effort. So appreciate the time and look forward to more conversation in the future.
So do I. Thank you very much, Cory.